Hello everyone. Hi, this is the last lecture, that is lecture number 5 of triangles. Right, in the last classes, in the lectures 1 to 4, we have seen similarity of triangles, congruency of triangles. We talked about various theorems, that is basic proportionality theorem, converse of basic proportionality theorem, and we also talked about Pythagoras theorem. So today we would be talking about a lot more things in this chapter, and we would be trying to finish off this chapter, right? So as I have been saying that this chapter is very important from your board's perspective, that is it consists of 9 marks, guys, 9 marks with options. So this is very important. So without wasting more times, we would be now moving on to the content, that is these things. These are the topics which we would be covering today, that is angle bisector theorem and important points with respect to triangle. What are the important points which are to be considered when you are talking about a triangle? Then we have midpoint theorem as well, right? So let's quickly start. So first we will be talking about angle bisectors. What are angle bisectors? So see, the interior, there are two different types of bisectors: interior angle bisector or internal angle bisector, and exterior angle bisector or external angle bisector. So interior or internal angle bisector is called as the line segment that divides the angle into two equal parts. Now if you just look at this figure, if you just look at this sketch which is below, in this triangle ABC, in this triangle ABC, we can see that angle BAD is equal to, or measure angle BAD is equal to measure angle DAC, right? Which means these two green angles are of equal measurement, right? So we would say AD is the internal bisector. Now, why do we call it as internal angle bisector? Because it is bisecting the internal angle A into two equal parts. So this is called as internal angle bisector, right? Now if you just look at the exterior angle A, so the exterior angle A, we have a measure angle CAE is equal to, or rather in the measure angle CAE is equal to measure angle EAF, right? Measure angle EAF, as these two red markings are shown, these two angles are equal. Therefore we would say AE is the external angle bisector. Correct, absolutely correct. AE is the external angle bisector, wherein we would say that AE is bisecting angle CAF, right? So this is about internal angle bisector and external angle bisectors. So the angle, the rays or the line segments which bisect the external angle are called as external angle bisector. The line segment which bisects the internal angle are called as internal angle bisector. Right. So now he's asking a question. Let's solve a pretty much simple question based on this knowledge. So we have the angle between the internal and external angle bisector. So first we need to spot that what are the bisectors. So we would say BE is internal angle bisector, right? Whereas BF is external angle bisector, right? BF is external angle bisector. Now we are interested in finding the angle between them, which means we have to find the value of x plus y, because x plus y is the angle between these two bisectors, that is the green ray and the blue ray. So what we will say, we know one important property, that is sum of all angles forming a straight line forming a straight line is 180 degrees. Is 180 degrees. Therefore, here all the angles are y plus x is equal to 180, which implies 2x plus 2y is 180 degrees. If we take out 2 common, we would say x plus y is 180, therefore which implies x plus y as 90 degrees, right? So here your x plus y ka value is 90 degrees, right? This is how we find the values of the angles between the bisectors, internal and external, right? So let's review this so we can see that the final answer is 90 degrees. Now comes the very important theorem, right? And that is the angle bisector theorem. What is the angle bisector theorem is what we need to now understand, right? So let's quickly see like what is angle bisector theorem. What does the statement say? The internal bisector of an angle of a triangle. So first we need to draw a triangle. So let's draw a triangle, right? In this triangle, in this triangle, the internal bisector of an angle. So let's name this triangle as ABC. The internal bisector of an angle. So we can consider any angle and its bisector. Let's consider as angle A's bisector. So we would say let the bisector of angle AB AD, right? This is AD, which is the angle bisector. What do we mean by angle bisector? That it divides angle A into two equal parts. That is, this part is equal to this part. Angle BAD, so we'll say angle BAD bad is equal to angle CAD. Right. Now it says the angle bisector of a triangle divides the opposite side internally in the ratios of the sides containing the angle. So basically he's trying to say that this angle bisector AD divides the opposite segment, that is BC, into two parts, that is BD upon DC, in the same ratio of the sides containing the angle, which means BD by DC is equal to AB by AC. AB by AC, right? AB by AC. So this is what angle bisector theorem is. That, and it's a very important theorem because it gives you a relation between sides of a triangle among themselves, which are in same proportion. This is a very important theorem, and this is known as angle bisector theorem, right? BD by DC is AB by AC. It divides internally in the same ratio as the sides containing the angles, right? Okay, now let's talk about different points with respect to a triangle, right? So we would be now concentrating on couple of different points. So the first point we have is centroid. So centroid of a triangle is the point at which the three medians meet. Now it is very important to understand what is a median. So you would say median is the line between the vertex and the midpoint of the opposite side. Vertex and the midpoint of the opposite side. So in this given triangle ABC, AD, BE and CF are the medians. AD, BE and CF are the medians, right? So we would say that the point of intersection of their medians, here it is denoted by G. This is a universal way to denote a triangle centroid. It is a universal way to denote centroid of a triangle by G. So there is this formula also, that is centroid of a triangle is given as, its x coordinate is given as x1 plus x2 plus x3 whole divided by 3, and its y coordinate is given as y1 plus y2 plus y3 whole divided by 3, right? So this is how we talk about a centroid and its uh, coordinate, x coordinate and y coordinate, right? So it is, we have to more note again that it is the point of concurrency of the medians. One more important thing is to note, that is centroid divides the median. The centroid itself divides the median internally in the ratio 2 is to 1, in the ratio 2 is to 1, which means if you all can see the figure here, AG by GD is always 2 by 1. So AG by GD, this is 2 by 1. Similarly, GC or CG by GF is also 2 by 1. And also BG by GE. All these ratios are internally divided into 2 is to 1, right? So yeah, and that, let's now solve a question based on this. So we have, find the coordinates of point of intersection of the medians. When it says clearly that you have to find point of intersection of the medians, which means we have to find the coordinates of centroid. Right, coordinates of centroid are x1 plus x2 plus x3. So it would be minus 2 plus 6 plus 4 divided by 3. And its y coordinate would be 3 plus 7 plus 1 divided by 3. So what do we get? 4 plus 6 is 10, 10 minus 2, 8, 8 by 3. And its y coordinate would be 8 plus 3, 11. It is 11 by 3. These are the coordinates of this centroid of the triangle, right? It's very simple. So this is very important point of the triangle, right? So let's quickly move to next point, and the next point is in center. In center, now what is in center of a triangle? We need to understand that is, uh, you can clearly see that the internal bisectors, again, which bisectors we are talking about? We are talking about angle bisectors. So the internal bisectors of the three vertical angles of the triangle are concurrent. Or concurrent means they meet at same point. This point of concurrency is called as the in center of the triangle. This point of concurrency is called as the in center of the triangle. This incenter here is denoted by I. This incenter is denoted by I. So here your AB is C. AB. Length of side AB is C. Right. Length of side BC is A. We can clearly see that it is A. And length of side AC is B. Right. The length of side AC is B. Now, if you can see the formula for in center, right, in center, it says ax1 plus bx2 plus cx3. What are x1, x2, x3? They are coordinates, x coordinates of vertices of the triangle, right? X coordinates of vertices of the triangle, right? And what are y1, y2, y3? They are y coordinates of the vertices of the triangle. Similarly, if you have to find, talk about in center, so you would say in center is ax1 plus bx2 plus cx3 whole divided by 3. This is the x coordinate, and the y coordinate is similarly like that, right? So now let's use this formula in a question. So we have a question. It says find the coordinates of in center of a triangle whose vertices are. So you have the vertices, that is A is 3 comma 1, right? This is your A. And you have B is 0 comma 1 and C is your minus 3 comma 1. You have to find coordinates of incenter, right? I. So it says when you have to find coordinates of incenter whose vertices are A, B, and C, then in that case we would be saying that first let's find the length of the sides because that is in the formula ax1 plus bx2. So we need to find A, B, and C. So we would say length of BC is nothing but A, which can be found out using distance formula, right? So what is the distance formula we have? Distance formula gives us distance between 2 points, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. So you would say that distance formula here, length of BC would be x2 minus x1, that is 0, minus of minus 3, that is plus 3 whole square, plus y2 minus y1, that is 1 minus 1 whole square. So here we get root of 9 plus 0, which is just 3. Similarly, this is what? This is length of BC. This is length of BC, right? So similarly, we can find length of AC. Length of AC is B. And how will you find length of AC again? So A and C would be 3 plus 3 whole square plus 1 minus 1 whole square. So again, this will give you root of 36, which is just 6. We need to find length of AB, which is just C, which can be found out as C is your AB ka length, which is 3 minus 0 square plus 1 minus 1 square, which is just 3 square, that is 3, right? So we have got our values of A, B, and C. We have x1, y1. So your x1 is 3, x2 is 0, and x3 is minus 3. We have y1 as 1, y2 as 1, and y3 also as 1. So we just need to plug in these values in the formula, that is in this formula ax1 plus bx2 plus cx3, and we need to get the answers. So let's see. So we are getting the incenter as 0 comma 1 after plugging in these values, right? So this is how we find incenters. Now the next important point is orthocenter. What is orthocenter? Orthocenter is the point of intersection. Orthocenter is the point of intersection of altitudes of the triangle, that is perpendiculars of the triangle, right? And they are concurrent. This is orthocenter, and the point of concurrence is called as orthocenter. It is denoted by O. Yeah, right? It is denoted by O. Correct. So right, let's move to next point. Then we have circumcenter. Circumcenter is a point of intersection of perpendicular bisectors. What do you mean a perpendicular bisector? So you have perpendicular, you can get as bisector. This is also bisector, and then we have this is also, these lengths are equal. So this points of concurrence is called as circumcenter, right? So there is one beautiful thing about circumcenter, that is considering the circumcenter as C, right? Like the midpoint of the circle, and taking this as radius, you can draw a circumcircle over the triangle, right? We can draw a circumcircle over this triangle. So circumcenter is actually the center of the circumcircle. This is called as circumcircle, right? So this is how what is interesting. Let's move to next. Now this is a very interesting point, and it's called as excenter. right? X-center. Now this figure might look very complex to you, but it is not. Let's try to understand how. So first let's read the definition, right? X-center of a triangle is the point of concurrency of bisectors. Okay, so we said, but point of concurrency was bisectors was in center. Now you are saying it's X center. So what is the difference between in center and X center is, in X center we have two exterior bisectors and one interior bisector. Yeah, right, one interior angle bisector. So if you just look at the figure, we have three angles, right? So there can be three different bisectors. So for triangle ABC, I'll just highlight that triangle. If you all can see the triangle ABC, right? This is our triangle ABC. Just concentrate at the triangle. For now, we can ignore these circles, right? So if we just look at the triangle, what we can say that angle bisector of A, but exterior angle. This is the exterior angle A. Iska bisector would be somewhere here, right? Its bisector would be somewhere here, right? This is bisector of exterior angle. Similarly, by exterior angle bisector for C, just look at the diagram, exterior angle bisector of C, right? These two are exterior. This is your exterior angle, right? This is your exterior angle and it's bisector because you are looking at a triangle. Now just think of angle B is interior angle, right? This is the interior angle and now we are trying to draw its internal bisector, right? Internal bisector. So this is the internal bisector. So we know, like, if this is the internal bisector and those are the two, then these three bisectors meet at one point and that point is called as X center. X center. So there are three X centers here, I1, I2 and I3, because here this is formed by external bisectors of B and C and internal bisector of A, right? I1. So I hope this you all understood what is in center, what is X center, what is circumcenter, what is ortho center, and what is centroid. So these are the most important points of a triangle, right? These are the most important points of a triangle which we were seeing. Now we have another important theorem of a triangle, and that is called as the midpoint theorem, right? That is called as the midpoint theorem, and it is a very important theorem because usually it is observed that questions from this topic and this theorem ka derivation is being asked many times in board examination, right? So let's see what does it say and let's also try to understand what do we how do we get to this result of the midpoint theorem. So it says the line drawn from the midpoint of one side of a triangle. So first of all, again, we need to draw a triangle, right? Line segment drawn. So we are drawing a triangle, right? Midpoint of one side of the triangle. We have triangle ABC parallel to the another side, right? So midpoint of one side, which means let's consider midpoint of side AB as point D parallel to another side. Now you can draw line segment DE, right? You can draw line segment DE which is parallel to BC because it is parallel to other side. So you would say let it cut the other side at third side at point E. So we are saying we are talking about three different sides. What is the first side? I mean D. D is the midpoint of AB. D is the midpoint of AB, which this is what we are given. Now segment DE is parallel to side BC. So we have talked about two sides now, AB and BC. What does it say bisects the third side? which means we have to prove that AE is equal to EC, or we have to prove that E is the midpoint of AC. E is the midpoint of AC, right? So let's quickly start with this proof. All right. So we have drawn the diagram now. Let's now also see its proof. So the very first thing we are saying that in triangle ABC, we know. What do we know? That segment DE is parallel to side BC. How do we know this? Because this is given. So using our favorite theorem, that is basic proportionality theorem, that is BPT, which we had studied in lecture 2. You will remember, guys, it was a so interesting theorem. So by basic proportionality theorem, we would say AD upon DB is equal to AE upon EC, right? AD upon DB is equal to AE upon EC. But what do we know? D is the midpoint, right? D is the midpoint of AB. Therefore, AD will be equal to DB, right? So similarly, we can say therefore AE also has to be equal to EC, hence proved, right? So this is how we say that uh, the midpoint theorem says that midpoint of one side of a triangle also bisects the other side, right? Now the same theorem is also applicable in a trapezium, right? The same theorem is also applicable in a trapezium. So we would say if the trapezium is ABCD, right? So we have a trapezium A, B, C, and D. Here it states that a line connecting the midpoints of two legs. What are the two legs? The two legs here are AD and BC, whereas P and Q are the midpoints. So what we are given, P and Q, P and Q are midpoints of AD and BC. P and Q are midpoints of AD and BC, right? So we would say midpoints of two legs is parallel to the basis, which means PQ is parallel to AB and PQ is parallel to CD also. PQ is parallel to CD, both of them, right? Then if these conditions satisfy, you all can see these arrows. This arrow means that they are parallel. So this PQ is parallel to AB and CD both, and P and Q are midpoints. So in that case, the length of PQ is half of sum of lengths of the bases, which means half of AB plus CD. PQ is half of AB plus CD. This is what midpoint theorem is, right? Midpoint theorem for a trapezium. So let's quickly try to solve a question based on this. So what does it say? If the parallel sides of a trapezium are 8 centimeter and 4, it is given that AB is 8 and CD is 4. M and N are the midpoints of the diagonals of the trapezium, which means AM is equal to MC, right? And we also are given that DN is equal to NB. Okay. So now what is the length of MN? So what we would say, first of all, we can get EF. How will we get EF? Using midpoint theorem in the trapezium, right? Midpoint theorem in the trapezium says EF, since E and F are the midpoints, na? Is this given E and F are the midpoints? You would say no. So E and F are not the midpoints. So you would say, it is not given that E and F are the midpoints, so you can't find EF, right? So you need to adopt some other approach for this. And what will be that approach? Let's see. So you would say consider triangle ADC. So inside this trapezium, you have a triangle ADC in which M is the midpoint, right? M is the midpoint of AC, right? M is the midpoint of AC. Therefore, using midpoint theorem, using MPT, so we have BPT, we have MPT. BPT is a basic proportionality theorem, MPT is midpoint proportionality theorem. So here your MPT would be ME is half of CD. EM is half of CD, right? Which is just 2. So 2 centimeter is your ME. Similarly, we can say NF is half of CD again, which is just 2, right? In triangle BCD you are talking about, right? Triangle BCD. So you would say now you have this as 2 centimeter. This is also 2 centimeter, right? Now we somehow need to find Mn, right? We need to find Mn. So for that, we would be needing to know that are these parallel sides A, B, and C, D. So you would say yes, they are parallel. So in that case, we would say EF is the mid segment of the trapezium. And if EF is the mid segment, then this is as a length of half times AB plus CD, that is 6 centimeter. Therefore, your Mn would be 6 minus 2, which is just 2 centimeter, right? So this is about midpoint theorem of a trapezium is. So I hope you all had a very fun interactive session and interesting session in triangles, and we had a clear understanding of all the theorems in the triangle and their converse, with starting from Pythagoras theorem, triangles, basic proportionality theorem, and all of that, right? So I hope you all are uh, continuing your preparations for other chapters also. So keep coming to Ask IITians and watch the videos. Thank you so much. Have a good day. Till then, stay safe and enjoy.